Now, the next is scientific method. Scientific method simply means the system or the way in which scientists perform or carry out their scientific work. Now, science is just like you being a detective. As a detective, you try to discover things, why they are so. What if I do this? What will be the result? Now, I'll be using a simple analogy of a plant. For instance, I walked out and I see a plant looking so beautiful. The first thing that would attract me to the plant is curiosity. I will be so curious. So for you to be very good with science, curiosity must be a trait in you. Now, the curiosity there is for me to wonder, wow, what is the magic or the principle behind this plant growing? This is the first aspect. I will be curious. Wow, why is the earth like this? Wow, why is this car running so fast? Now, when you're curious, the next thing that takes place is observation. Now, you begin to observe. Now, also that plant, I'll begin to observe what are the physical attributes of this plant. Okay, what is its color? What is the height? What is the size of the leaves? Are they narrow leaves? Are they broadened? So all these are things that you observe. When you observe, then you start asking questions. What are the questions you begin to ask? I will start asking questions. Okay, this plant, if I should grow it in a place where it does not receive much sunlight, what would be its result? What would be its yield? If I should grow it in a place where I don't give it much water, what will be its result? So these are questions. Scientists ask a lot of questions. So you ask questions. Now, when you don't asking questions, this leads to hypothesis. Now, in hypothesis, you are simply trying to state some assumptions. You're trying to state some assumption. I could look at that plant and say, okay, for this plant to grow well, it does not need much sunlight. That is an assumption. For this plant to grow well, you must water it every day. These are assumptions, and all these assumptions fall under hypothesis. Now, you don't just stop at that. As a scientist, you now carry out experiments. Now, for you to perform the experiment, you begin to say, okay, now let me grow some of these crops or these plants where it will receive much sunlight. Let me grow some in a place where it will not receive much sunlight. Let me water some of them, and some of them let me leave it without water. After you've carried out this experiment, you now collect your results. Now, that your results will now validate if your hypothesis is correct or not. If your hypothesis is not correct, you don't take it. Therefore, you create a new standard. Result and your conclusion. And one thing about science is that you don't guess in science. Your results should not be a guesswork. Someone else should be able to replicate this and also get the same result. So therefore, you can't talk about physics without science, and you can't talk about physics without not having the attributes of all this. You should be curious, you should be able to observe, you should be able to ask questions, carry out hypotheses, perform some experiments, and get some results which are authenticated, and other people can also replicate and perform it and also get the same thing. So remember, the building block of science, the natural science, is matter and energy. And matter and energy is all studied under physics. So that is why physics is very, very important. So in our next class, we will be going into the next aspect, which is the fundamental. What are physics? What are the next steps? What are motion and everything? We will be taking it gradually, step by step, so that you can easily understand it and be able to replicate what I am teaching. Okay? So do well to share this video, invite others so that they could also learn from this. Bye for now. In case you have any questions, drop it in the comment section. See you in the next video. Bye.